Hi, and welcome to the Digital Tutors Advanced Fluid Effects Training Kit. In this kit, we're going to be covering a lot of aspects of Maya fluids, and some of these examples that we're going to be looking at are going to go far beyond the typical gas and fluid simulations that you're probably used to seeing with Maya fluids. So just to show a few of the examples that we'll be talking about, we have things like advanced combustion effects. So we're going to be building this flame completely from scratch, and we'll use this as sort of a segue to talk about a lot of these advanced fluid attributes and how these attributes really work together, and really understanding the way that these different attributes interact to be able to simulate something like this realistic fire. We'll also talk about using expressions to generate ripples in a fluid based on particle collisions. We'll also talk about your typical realistic liquid simulations, so how you could use Maya fluids to really get nice, realistic flowing water. Okay, we'll also talk about some more advanced combustion effects, so being able to have fire actually burn and combust along a predefined path that you can build within your fluid container. And then also we'll talk about some fairly non-standard uses for Maya. Things like being able to simulate soft surfaces like mud or snow, and how you can have your objects interact with these sort of soft surfaces. And then we'll also take a look at just some really unusual examples, so sort of some cartoon effects, and how we could really use Maya fluids to simulate and get some of these effects that are really difficult to achieve otherwise. So we have a lot of things to talk about, so in the next lesson we'll go ahead and get started. In this first lesson of the Digital Tutors Advanced Fluids Kit, we'll look at the principles of using Maya's fields together with fluids to achieve a nice mist or a spray type look using Maya fluids. So let's go ahead and take a look at the scene that we'll be working with. And what we've got set up in this scene is just a fire extinguisher that's got the hose moving around on it. Okay, now what we'll do in this lesson is actually use fluids to give a nice mist that's coming out of this fire extinguisher, and then actually later on have that mist interacting and floating and swirling around objects. Okay, so let's go ahead and first of all add our 3D container. Okay, and we talked about in the previous Digital Tutors Fluids Kit about several ways to actually go about expanding and resizing your fluids. One of which you could scale it, which is really not recommended because as you scale this up, you're actually making the voxels bigger. So not really recommended. Again, if you were to select this and open up the attributes, you could adjust the size here in the attribute editor. Again, whenever you do this, it's actually going to make your voxels larger. So now you've got to go in and think about, okay, how big did I make it? Now, how big do I need to adjust the resolution? It can really be kind of time consuming and really more hassle than it needs to be. So a very easy way to go about expanding the fluids is to actually go to Fluid Effects and let's extend the fluid. And we'll go to the options, and this will pretty much tell you you can expand and resize the fluid by however many units you want in whichever axis you want. So let's say 8 units in the X, Y, and Z axis. Okay, so that's the number that we'll set, 8 all around. Apply it. Now you can see it actually resized it, but one thing that it did also do was that it resized these voxels for us. And if we go to the attribute editor, you can see that in addition to adjusting the size, it also automatically proportionately adjusted the resolution of the voxels. So that's a very, very nice feature to have. Okay, so now that we've got the container set up, let's go ahead and position it to wherever we might need it. So since we really don't need the fluid container to be completely surrounding this fire extinguisher, let's just move it forward a little bit. So now that we have the container, let's now add the emitter. So we'll go to Fluid Effects, let's add Edit Contents, and let's add an emitter. Okay, so here's the emitter now. Now what we want to be able to do is take this emitter and actually parent it to this nozzle so that as the nozzle moves around, you actually have now your fluids coming out of that nozzle. So let's go ahead and pick a nice view. Let's go ahead and get this emitter set up into place. Okay, we'll go ahead and pull this up to where it's pretty much inside the nozzle. Now we'll just select the emitter, Shift select the nozzle, and let's parent this. So now what we should have when we play this back is you have the emitter that's now moving along with this nozzle and now leaving the fluids behind. Okay, you can see though by looking at this we really have got quite a bit of work to do before we actually have something that looks like the foam or the material that actually usually comes out of these fire extinguishers. So let's select the emitter first of all, and let's go to the attributes. And one of the first things we want to do is let's first of all change the emitter type from Omni to volume. Okay, and this will pretty much just overall let more fluids come out of this object. Okay, we'll go ahead and set the volume shape to a sphere, so we have something that's size-wise a little more suited for this rounded nozzle. Okay, let's go ahead and we'll also need to give this a lot higher density in this emitter, so that way the actual foam or the mist that it's going to be emitting is now much darker. Okay, that's getting better. Let's also, while we're working with this emitter, let's turn off this jitter checkbox, which is going to be turned on by default. What will happen when you turn this jitter off is we now should, instead of having these sort of chunks and sort of the sputtering of these fluids, you can see now how it's kind of emitting in these little sputters. Let's take this jitter off and play this back, and we should have something that's a little bit cleaner as far as the overall emission of this. Okay, that's a little better. So let's go ahead, and now that we've got this pretty much set up, we're ready to now go in and start to add the dynamic fields to actually move this foam wherever we need it. So let's select the container first of all. What you'll do whenever using these fields is select the container that you actually want these fields to be able to affect. And let's now go up to fields and let's add an air field. Okay, and the air field by default is going to be put at your 0 axis. So here it is right now, actually inside of my fire extinguisher. So we'll just pull this forward. Now what we need to be able to do is put this air field up here by the nozzle. So that way it gives the effect of this nozzle actually exerting a force on these fluids. So with this air field selected, let's shift select the nozzle. And now under the fields, let's go up to use selected as source of field. When we do that, it looks like our air field has pretty much disappeared. But if you go to your wireframe view, you'll see it's actually now inside of the nozzle. Okay, so let's go ahead and take a look at the attributes for this air field. Actually, let's first of all play this back, and let's see what just adding this air field has done without making any changes whatsoever. You can see playing this back, it really doesn't look like anything at all is happening. Doesn't look like that air field's really doing much of anything. Well, the problem is when we select this air field and take a look at the magnitude by default is going to be set to 0, meaning it's really not doing much of anything at all. So let's give this a much higher magnitude. Let's say something like 40. And let's give this a much higher speed, something like 100. Okay, and let's go ahead and just first of all see what this is doing. Okay, again, not just a whole lot. You can see that there is now a little bit of movement happening, but it's actually moving in the wrong direction. This is moving up rather than moving out, away from the nozzle. Okay, few reasons for that. Well, the main reason is this direction of the airfield. By default, it's going to be set to actually push the air up in the y-axis. So let's turn that to 0. And taking a look at these axis indicators, we actually would want to be able to move this in the x-axis. So let's set the x-axis direction to 1. And let's take a look at this max distance of the airfield. And pretty much what that max distance is talking about, that's pretty much the maximum distance from the airfield at which this field can be exerted. So a higher number means it's going to have a greater effect. So let's say something like 6 as the max distance. And now when we play this, we now can actually see some uh, force being exerted on these fluids. So that's much closer to what we would actually want. So let me go ahead and let this play through really quickly. So you can see now as these fluids are being emitted from this nozzle, we actually now have some force pushing these fluids away in whatever direction we would want. Okay, so let's go ahead and render this real quick and see what we've got. Okay, so now we've actually got some dynamic forces pushing these fluids away from the nozzle. But you can see looking at this, we still have got a little bit more work to do. So in the next lesson, we'll go ahead and keep refining the actual fluid container and put the finishing touches on this fire extinguisher. In the previous lesson, we talked about using fields in conjunction with Maya's fluids. So in this lesson, let's talk about making refinements to the container properties of the fluid, and also we'll talk about using collision objects within your fluids to actually adjust the way that these fluids behave. So let's go ahead and pick up where we left off in the previous lesson. And in the previous lesson, we were actually able to get this fluid to move properly out of this nozzle and get a little bit of movement behind it in the right direction. But now we run into the problem of that this fluid really doesn't look like what you would expect to see with a fire extinguisher. It still looks awful misty and just really more like a light wisp of smoke that's coming out of this, as opposed to like really pressurized fire extinguisher. So in the previous lesson, we talked about actually getting that effect. Now let's talk about making adjustments to the overall look of this fluid as it's coming out. So let's select the fluid container, and what we'll do is we'll go to the fluid shape in the attributes, and let's take a look at the contents details of this. Let's go ahead and take a look at the velocity and the density, and just a couple of things we need to adjust. Let's go ahead and give this just a little bit of dissipation so that as time goes on, this fluid will sort of dissipate and die away. Let's also give this a little bit of swirl. Let's say something like 5. That way, this stuff can actually sort of swirl and look a little bit more like a gas as this is coming out. Let's go ahead and play this back real quick, and you probably won't see a huge amount of difference at this point because there's still a couple of other changes that we need to be able to make with this. So you can see the fluid actually strikes the surface of this container, and you can see a little bit of the actual swirling happening. So let's go ahead and take a look at the shading for this. And what we're going to be looking for is the opacity graph for this fluid. So what I want to be able to do is, let's first of all play this simulation through. I actually want to be able to get sort of toward the end of this so I can actually see the effect that this opacity graph is going to be having on the final look of these fluids. Okay, so I've stopped pretty much toward the end of this simulation. Now the fluids have kind of started to collide with this surface. Now I can see a little better of what I'm going to be doing with this opacity graph. This opacity graph can give you a huge amount of control over the overall look of your fluids. So you can see if I actually start to increase this, you can actually start to see some fluids actually in the middle of our container. The reason for this is that the physics behind Maya's fluids is that the container is actually always full of fluids. So that as you actually adjust the density, you can actually see these fluids become visible. But in reality, this container is actually always full of fluids. So by adjusting the opacity, what we're doing is actually making those fluids that are always there visible. So that's what's actually happening when you raise this first opacity graph. But what we can also go in and actually add a little bit more and maybe bring it down a little bit here toward the end. So you can see that in itself has made a huge adjustments to just the overall look of this. We now have something that's much thicker looking and not just this wispy sort of a smoke look. So what we should now see is when we play this through, we now have something that's much denser okay, and much closer to what we would actually expect from a pressurized fire extinguisher. So now it hits that surface of the container, and now actually starts to sort of wisp and billow out, which is really what we would want. Okay, so now at this point, we've pretty much got the fluid where we want it, as far as having sort of a pressurized fire extinguisher look. But let's go ahead and just really quickly set up a collision object. So the collision object can be pretty much anything you want as far as a surface. Let's actually make a NURBS torus, and we'll drop it into the middle of our scene. Okay, and like I said, a collision object can pretty much be polygon, NURBS, subdivision, pretty much anything you want. So we can go ahead and set this up to where we would want it. Okay, now let's go ahead and play this back. And by default, when you play this through, really it's kind of what you would expect to see with particles. The fluids just pass right through this object and really has no effect at all. But let's actually stop this, and let's select the object itself, and we'll also select the fluid container. And now we'll go up to Fluid Effects, and we'll tell this to make collide. So we'll go ahead and now play this through. And what we should now see is these fluids actually interacting with this NURBS surface. And it's sort of hard to see, but they actually do. You can see that the fluids have sort of passed around this object and are bouncing off of it. Okay, that's pretty much what we would expect to see. So I'm going to go ahead and real quickly open up a rendered image of what we've got. Okay, and this is just a rendered sequence of the scene that we just looked at. So you can see pretty much what we would expect to see. We have now the fluids that are able to actually interact with this NURBS torus. So you can see they're sort of blasting off that surface. And then as they actually hit the backside, they actually sort of spread out and billow and swirl and now dissipate nicely. So this is how we can use fluids to achieve sort of a nice pressurized gas that's coming out of something like, for example, a fire extinguisher. So in the next lesson, we'll start to look at how we can use fluids in conjunction with Maya's particles to adjust things like density and color to achieve very nice interactive textures within Maya. In this lesson, and actually for the next several lessons, we're going to be talking about particles. Now specifically, we're going to be talking about how we can use particles to actually interact with fluids and generate some very nice, very realistic water effects. So let's go ahead and take a look at just a blank scene. And what I'll do first of all is let's add a few elements to this scene. And then I'll kind of get to talk about exactly what we're going to be working with and exactly what we're going to be doing. Let's first of all add to our scene a fluid texture 2D. So you can see it'll add a 2D texture and it'll also add a 2D fluid container. Now the first thing we need to do with this container is let's get it to where it's pretty much lying flat on the ground. So if we take a look at this, we're going to rotate this about -90 in the x-axis, so that way it's laying down pretty much flat. Okay, let's also add to this a NURBS plane. Now it's going to be important that we use a NURBS plane for this, because what we'll be doing over the course of the next couple of lessons is actually getting the U and V coordinate data off of this NURBS plane to actually generate ripples on this 2D container. So let's go ahead and scale this to where this NURBS plane is pretty much the same size as this container. So it looks like about 10 scale, and that'll get it to the pretty much the exact same size. So like I said, what we'll be doing is using particles to actually hit this NURBS surface. And then what we'll do is write an expression that's able to take the information of where that particle hit and actually generate a ripple on this 2D texture in the appropriate spot. So this is how we can do things like simulating rainfall, falling into a puddle, and actually generating ripples. And that's pretty much what we're going to be doing. So before we go on much further, let's take this 2D container. Okay, let's go to the 2D shape. And what we're going to be doing is let's change the solver on this. Go ahead and expand this. Okay, let's go up to Dynamic Simulation. And what we'll do is let's first of all change the solver from Navier-Stokes. What we need to do is change this to a spring mesh. And that'll actually give us the ability to generate these ripples at a later point in time. Okay, so that's a very important step, changing this to a spring mesh solver. Okay, now let's go ahead and get the particles set up on this. So what we could do, just a very easy way to do this, let's duplicate this NURBS surface and move it up. And now what we can do is actually make particles emit from this surface. So let's go ahead and under Particles, let's go Emit from Object. And when we play this back, you can see the particles are coming out of this object. Let's go ahead and go to the emitter of this, and let's change the emitter from an Omni to Surface. Okay, now we have something that looks a little bit more random as far as being generated from this surface. And as the last step, let's go ahead and add a gravity field to this. Okay, now when we play this, we have what's going to pretty much be our falling rain. Okay, and these particles will be what we actually use to generate the ripples in this water. Okay, now we may need to actually go in and maybe make a few less particles. Let's say maybe like 10, just so we don't have an enormous amount of rain falling. Maybe something like that, just kind of a nice little rain shower. Okay, now the first thing that we need to be able to do before we can actually use this particle data is we actually need to have it colliding with this surface, because when these particles start to collide with this secondary NURBS surface, Maya in the background is actually going to be gathering information about exactly where that particle hit. So that's the first step we need to do. Let's take these two and let's go under Particles, let's make Collide. And now what we should see when we play this through is these particles actually hit and then bounce off. Now they're not bouncing off like real rain actually would, but that's okay. We'll deal with this here in just a little bit. Okay, actually before I move on, one thing that we do need to do is let's select these particles. And one of the things that we're going to actually need to calculate on this is the collision U and V data on this surface. Okay, so right now if we select these particles, and if we look underneath the per particle attributes, which that should be found under particle shape, let's go to the per particle attributes, and pretty much everything that we need is there, but a couple of things that we actually need are not in these array attributes, and one of those are collision U and collision V. So the fact that they're not there, it's not a big deal. Let's go ahead and go to Add Dynamic Attributes, and let's go to General. Okay, we'll go to the Particle tab, and now here's a list of the things that have the ability to be added to these array attributes. So the two that we need are collision U and V. Let's hit Add. Okay, and if you look closely, you can now see the collision U and V have been added to these per particle attributes. So once we've done that, we can just close this. And now what we'll do is, now that we have these added, now we'll actually go in and start to write an expression that can actually use this particle collision data to add density to this 2D container. And by adding density in the object into just the places where these particles collide, what we'll basically get out of this is a ripple. Okay, and it'll basically just look like a puddle on the ground, and whenever a raindrop falls into it, you'll get that ripple effect, and it'll look really, really nice, but it's going to take a little bit of expression writing to be able to actually get that. So let's go ahead and under collision U or V, either one really doesn't matter, let's right click and let's make a runtime expression before dynamics. Okay, and when we do that, it will open up the expression editor, and now we can actually write the expression, which in the next lesson we'll actually start to write the expression for these particles. Okay, in the previous lesson we talked about how to set up a scene for the puddle. So what we're going to be doing now in this scene is focusing on writing an expression. and it's going to be an expression that can basically take the particle collision data and generate these very nice water ripples based on those particle collisions. So here's where we left off in Maya with the expression editor, getting ready to pretty much type in the expression that we need. But just for convenience sake, because I'm kind of limited on space in this expression editor, I'm going to go ahead and just type the expression itself in Notepad, just so you can see a little easier exactly what I'm going to be doing. Now, because this is an advanced kit, I'm going to assume that you probably have a little bit of experience in writing expressions and writing MEL. If that's something that you're not just intimately familiar with, I would very highly recommend picking up the Digital Tutors MEL Basics Kit, which is going to do a fabulous, fabulous job of talking about things like syntax, loops, a lot of things that unfortunately, just for time's sake, I'm not going to have a whole lot of time to cover. So let's just really quickly write just a little debugging script that'll let us see if Maya is in fact capturing this collision data. So let's start by adding a float variable, and let's call that float variable collision u. Okay, now let's define what that is, and collision u is going to be particle shape 1 collision u. Okay, we'll also make another float variable called collision v, and collision v is going to be particle shape 1, and it's going to be collision v. Okay, I'm going to go ahead and make sure that I actually end these lines. Okay, now let's make a quick little if loop, and what we're going to say is if the variable collision u is greater than 0. Oh, let me go back. Nope. Try that again. There we go. Okay, so if the collision u is greater than 0, so pretty much if any collision at all happens, then let's tell it to let us know by printing whatever message we tell it to. So you can tell it to let you know in any way you want. So let's tell it to print the word hit. Okay, I'm going to go ahead and end this. And let me go ahead and close this loop. Okay, so if any collision at all happens, let me know by printing the word hit in my script editor. So let me go ahead and copy this, and I'll just paste this back into Maya. Okay, now no errors were reported back, so everything looks good. Let me go ahead and I'll just clear the history in the script editor, just to remove some of this other junk that used to be up there. Okay, let me play this back, and I now get the word hit back. So that's how I can tell that Maya is actually recognizing these collisions, because I get the word hit back. So now that I know that it actually is registering these collisions, now I can go back and actually add the data that's relevant. Okay, so I'm going to go ahead and leave this loop. I'm just going to remove this print line, and now let's tell it what we want it to do. So let's say set fluid attribute, and let's tell it to set the x index to the same value as collision u, and we'll tell it to set the y index to the same value as collision v. And now we'll tell the attributes that we want it to alter. So let's set the attribute of density. We're going to set a little flag that tells it to add a float value of 0.6, or pretty much any value you want. Okay, so we're going to be altering a fluid attribute by looking at the x index and the y index. Okay, and what that is pretty much the rows and the columns, or the rows and the rows running horizontally, columns running vertically for the x and the y axis. Okay, so it's going to look at that and say, okay, for all these rows and all these columns, go ahead and compare that to the collision U and V data of this NURBS surface. And wherever a collision occurs, it's basically going to add a float value of 0.6 to the density. Okay, but right now we still need to tell it what surface we're going to be adding these values to, and that's going to be this fluid 2D texture shape 1. That's what we want to be able to actually add the density to. So let me go ahead and tell it to add float value of 0.6 to fluid texture, fluid texture, and it's going to be fluid texture 2D shape 1. Okay, I'll go ahead and stop this line. Okay, so we pretty much told it wherever a collision happens, we're going to add a density, and we're going to add a density of 0.6 to this fluid 2D texture. Okay, now let's copy this, and let's go ahead and open the expression editor back up. So to get to this manually, let's go to Window, Animation Editor, Expression Editor. Okay, we'll tell it to select the filter. Let's go by expression name. And what that'll do is pretty much show us all of the expressions that we have in our scene currently. Right now we've just got this one expression. So let me go ahead and select all this, paste this new expression back in. Let's edit this. Okay, now no errors were reported back, so apparently everything is good. Let's go ahead and do pretty much what we did before. Let's clear the history. Okay, and let's play this back to make sure what we get. Okay, so you can actually see now there are some ripples that are happening. So let me play this back. Okay, if you look, you can see these ripples that are being generated. And again, this is because we're telling it wherever these particles collide, I want you at that point to add a density of 0.6. Okay, although looking at this, you can see we definitely do have some problems. These collisions are only happening in the corner of our NURBS object, and we are actually getting these errors back in the script editor. And basically what it says is it cannot convert a float value to a integer value of 0. And basically what that is just a pretty simple thing that we can fix in our script. So in the next lesson, now that we've got this rough skeleton of a script set up, in the next lesson we'll go in and actually refine this script so that we no longer get these errors back, and it actually will generate the density in the correct places. Continuing from the previous lesson, we need to fix some errors that have occurred with getting our particles to interact with the 2D fluid container. Now those errors can be fixed by just adding a couple of lines to our script. So looking at this, where we left off from the previous lesson, we have this error that's coming up that says it's having a problem converting this float value of whatever it happens to be, so it's going to go ahead and make it 0. Now basically what it says is, I don't know what to do with these float variables. In other words, it's a float variable is anything that has a decimal point in it. It says, I don't know what to do with these float variables or these float values, so I'm just going to go ahead and make all these collisions happen at 0, which is why we only have that one collision happening down in this corner. So, okay, now the thing that's actually causing that is the resolution of this container. So it's a pretty simple problem to fix. What we can do in our script is just take the resolution of our container and multiply that fluid resolution with the collision data so that we actually have something that maps out correctly. So what we need to do, let's go ahead and add just a couple of lines to this. So let's make, first of all, an integer. And an integer is going to be a whole number. So let's make an integer variable. And let's call that variable, you can pretty much call it anything you want. Let's call it x position. Okay, and that x position is going to be the fluid texture, fluid texture 2D shape 1, and it's going to be resolution width. And what we'll do is we'll take this resolution width and multiply it with collision U. Okay, we'll do the same thing. We'll make another integer, and we'll call this one Y position. Or again, you can call it pretty much anything you want. And just to save me the time of having to retype all this, I'll just go ahead and copy this, paste it, and this is going to be collision, or the resolution height. So X position and Y position, which is pretty much going to be the height and width resolution, we'll take those and just multiply those with these collision U and V. Okay, let me go ahead and make sure that I terminate these lines. Actually, stop these lines. Okay, let's see if that works. Let's copy this. Okay, go back to my expression editor, and we'll paste all this back in. Let's edit that. And let's see, resolution. Okay, it looks like I had a little bit of a typo here. Resolution height and width, I guess those don't need to be capitalized, looks like. Alright, let me try that. Okay, so we'll copy this. Let's try that. Paste that. Edit. Okay, there we go. Go ahead and play this back, and let's see what we get. Hopefully what we'll see, and let me go ahead and let's try this again. Looks like we're still having a little bit of an error here. So what we need to do is, looking at this, we still need to add just a couple more things to this. So what we need to do is, in this fluid attribute, in this X index and Y index, we need to replace the collision U with this Y and X position. So let's say with this, let's replace that with X position, and Y index, we'll replace that with the Y position. Okay, let's see what we got now. Let's copy this. Okay, I'll go ahead and paste this back into my expression editor. Okay, let's go ahead and play this back. See, okay, now we've actually got these ripples that are happening on the water surface. Now that we've actually managed to get this script working correctly, we do though have a couple of issues, just one little issue still, and that is we now have way too many ripples. And that's because these particles, they bounce up, and when they come back down, we now have more ripples than what we started out with. So let's add just one quick little line into our expression that will pretty much tell these particles, once you hit this surface, go ahead and just die. You know, don't exist any longer. Alright, so let's add just one more line to this. Okay, and right underneath this fluid 2D texture shape 1, let's add one more line that says, let me go ahead and retype this. We're going to say particle shape 1, particle shape 1, okay, and that is this actual particle system that we have. Okay, particle shape 1. We're going to say, okay, particle shape 1, your lifespan per particle is going to be 0. Okay, and it's going to be 0. Okay, so in other words, once it comes in contact, once all of this happens, you know, once you collide with the surface, add the density, go ahead and die. So let's copy this. And back to the expression editor. Go ahead, paste this. Okay. Let's see what we got now. Go ahead and rewind this, play it back, and what should happen now, nope, they're not dying yet. You go back and double check this real quick. And the expression looks okay. I know what I forgot to do. What we need to do is select this particle shape, and I forgot to set the lifespan mode to lifespan per particle. So right now I have it set to live forever, which is pretty much just ignoring this last line that we put in this script. Okay, so that's what we forgot to do. Switch the lifespan to per particle. So now it will actually obey this per particle command that we've given it. Okay, let's try that. Now, go ahead and hit play. Let this thing play through. And now we get pretty much what we would expect. We now have these particles, as soon as they strike this surface, now they just die. And it's actually giving us these really nice ripples on this 2D texture shape. Or on this 2D fluid texture. So now we've actually got this 2D fluid texture. But the problem is, now if I stop this, and if I were to just render this, we don't get anything back. That's because right now we're just dealing with a texture. This texture still has to be assigned to a surface for it to actually show up. So what we could do is let's actually make a new material. Okay, and if you take a look at this, you can actually see this 2D fluid texture shape. It has actually got all these ripples applied to it. So if we were to take this and apply this to a new material as a color map, assign the material to the selection, so if I play this back, you can now see, okay, these particles are actually generating this on the 2D fluid texture, and now that texture has been assigned to this plane. So now if I render this, you can actually see this plane has got these ripples that are occurring on it. Now right now, if you look at this, you can see these ripples are kind of rough looking. So what we could do is let's select this 2D fluid texture, and let's raise the resolution on this to something like 100 and 100. Okay, and when we play this back, it'll play back a little slower, but now these ripples are a little bit more accurate. They're not quite so blocky. And you may even need to take these up even higher if you want to be able to use these for what we're about to use these for in the next lesson. So let's say maybe 200 and 200. Go ahead and play this back, and again you'll see that these definitely start to play back a lot slower as you raise this resolution higher and higher. And you can see also, because we're using a much smaller resolution, now these ripples also appear to be a little bit smaller as well. So something to keep in mind. Okay, so now that we've pretty much got this expression set up and everything's ready to go, now we can actually start to use this in a scene. So what we'll do in the next lesson is make just a quick little scene for this puddle to actually sit in, and then actually make that puddle to where it can interact with its surroundings. So as it's sitting inside of a indention, we'll make it to where as these ripples hit that indention, they actually will ripple back. So that's what we'll do in the next lesson. Now that we have the rain puddle set up and have the expressions working the way we want, now we're ready to go in and actually build a scene with this. So let's go ahead and pick up where we left off. And like I was saying in the last video, the problem that we have with this right now is that this really isn't a renderable surface. So what we're going to have to do is take this fluid texture and then assign this as a texture to a NURB surface. Or we could even apply this as a bump map or even a displacement map to this, since we're pretty much just getting grayscale information back. So I'm going to go ahead and select this, and just for speed's sake, I'm going to go ahead and lower this resolution a bit. Okay, I'm going to go ahead, play this through, and make sure everything looks the way we need to. Okay, so just for visualization's sake, I think this will work. I'll go ahead and take this, and for accuracy's sake, I'm going to go ahead and put these two planes down to where they're pretty much right on top of each other. This will help with accuracy here in just a little bit when we have to actually make this 2D fluid collide with another surface. That's going to be pretty important that these two pretty much be at the same position. Okay, so if we render this, okay, we pretty much just have an empty NURBS plane. So let me go ahead and we'll make a new material for this NURBS plane, and we'll assign to this 2D fluid texture. Let's go ahead and assign this as the bump map. Okay, we'll go ahead and drop this on. Make sure that that takes. Go ahead and play this through. Okay, now let's go ahead and render this and let's see what we've got now. And you can actually see the bump map that's now being applied to this NURBS plane. Now because we turned the resolution down, that's why this looks really blocky and really pixelated. That's okay though, because this is actually, just like I said, for visualization purposes. Once we get this the way we want it, we can take this resolution back up. So I'm going to go ahead and I'm going to add into this a NURBS plane. And you really don't have to use a NURBS object for what we're about to do. You can actually use pretty much any surface you want. So let me go ahead and turn off this grid, just so that it's not in the way. And just to make this plane a little easier to see, I'll go ahead and make it a little different color. So I'll go ahead and select this. And I just pretty much just added in a new Lambert, which will be the ground. Okay, so what we're going to be doing is actually sort of modeling a little bit of a puddle for this water to sit in. So I'm going to go ahead and let's take up the U and V patches on this ground NURBS plane. Let's say something like 10 and 10, maybe even a little bit higher. Let's say maybe 30 if we wanted to actually be able to sculpt something pretty nice. So what I can do is go back to the modeling menu and let's take a look at the NURBS sculpting tool. Sculpt surfaces. Go to the options. And let's start off by telling this to push down on the surface. Okay, I'm going to hold down on the B key, B for brush, to go ahead and adjust the brush size. And now I can just push down on this. And I might even want to take these two and actually make a new layer out of these. Add selected objects. So just that way, these are just pretty much out of the way. Go ahead and mold this down a little bit. Okay, let's go ahead and take a look at that. Turn these back on. Okay, let's try moving these down. Okay, so that way these can actually sit down inside of this puddle that we were just able to make. So let me go ahead and actually take a few more of these vertices. And let's just pull these down a little bit more. Okay, just really quickly. Okay, go ahead and take a quick render of this real quick. Go ahead and let this play through. Move this down a little bit lower just so we can watch this as it simulates. Okay, let's render this real quick. Okay, and we get pretty much what we would expect to see. We sort of have this little puddle where these raindrops are falling. The problem though that we have with this is that you can see that these ripples are not interacting with the edge of this puddle. What we would normally see is once these ripples actually go to the edge, they would normally rebound and then just come right back, which they're really not doing right now. So what we need to be able to do is make a collision surface for these fluids to interact with. Now, one problem that we could have with this is because we're dealing with such a large plane, the Maya is actually going to be looking for collisions all along this entire surface, which could actually bog down our system quite a bit. So what we could do is actually detach some of these surfaces to where we actually have a much smaller NURB surface just in this area for this to have to calculate. Okay, and like I said, you could do this with either polygons or NURBs. It doesn't really matter. So let's select a couple of isoparms, and let's detach this. Okay, let's take another couple of isoparms, and we'll detach these. Okay, so now I have just a smaller NURBS plane for these to have to interact with. Okay, I'll go ahead and select the 2D fluid, not the NURBS itself, but the 2D fluid, which could sometimes be a little bit of a pain to try and grab. NURBS plane, there we go. So let's take the fluid and then shift select this detached surface, and back underneath the fluids, let's go back to dynamics, let's go to fluid effects, and let's tell these to collide. Okay, we'll go ahead and play this back, and hopefully what we should see is these ripples actually hit the surface and then start to rebound back. So we'll let this play back one more time. Nope, didn't stop it quite in time. Okay, so let me go ahead and render this real quickly. Okay, and it's sort of hard to see, but these fluids are actually now rebounding off of this surface, which is really what we want. So as I play this through, although looking at this, we do have a pretty serious problem when we play this back. If you look really, really closely, you can see that there's a few of these particles that when they hit this surface, they get stuck. Okay, and that's just a problem with this collision surface. There's sort of an area of no influence, I guess you could call it, that if a particle lands just right on this boundary in just the right place, it's not going to know what to do, and so it gets stuck, like you can see with some of these. So the easiest way that I found to be able to fix that is let's take this NURBS surface and let's duplicate this. Okay, so that we actually have two of these NURBS surfaces. Now we'll go ahead and select the one that has actually been set up to interact. And you should be able to tell, because the one that you select, if it's set to interact, you should be able to see this fluid shape actually turn sort of a pink color. So to fix this, let's go ahead and just make this NURBS surface a little larger, so that this area of no influence is pretty much hidden. Okay, we'll go ahead and play this back and see if we still have this same problem. Still have it a little bit. Let's go ahead and maybe scale this out a little bit more. Play this through. And it's now much, much less. So the idea is to find just kind of a happy medium to where it will still collide and still ripple along these edges, but it won't get stuck. So when again, we've got these two NURBS surfaces that are actually causing this. Now, if this one happens to be getting in the way, we could always just hide this. So we could select this NURBS surface, hide it, and it'll still register the collisions, but it just won't render. Okay, we may also want to make this a little bit larger so that it drops particles over these larger areas. Go ahead and play this back. And same that you did with the NURBS collision surface, we can also hide this. Control H to hide. So now that it's hidden, the particles will still drop and still land, but they just, you won't be able to render that surface. So now you can get things like reflection of a sky and just a real nice scene set up. So now when we play this back, you can see we no longer have any of these particles being stuck because they're interacting with that larger NURBS plane. So I'll go ahead and pull up a rendered scene of what we just created. Okay, and here's the scene that we just built. This water ripple has been applied as the displacement map to this NURBS plane, and what we have is just these really nice water ripples that are just being created by these particles striking this surface and just adding that one little bit of density right in those points. So that's how we can use particles together with these fluids to generate some really nice, realistic water effects. The next couple of lessons will be dedicated to exploring some of the advanced fluids attributes and how they work together. So what we'll be doing in this lesson is exploring some of these attributes to make fire completely from scratch, and then we'll use that fire at a later lesson in this kit. So let's go ahead and just start with a fresh scene, and we'll be making this fire, like I said, completely from scratch. So let's go ahead and start off with a 3D container and an emitter. Okay, and if I play this back, you can see we really don't have anything too exciting, just the typical 3D steam. Nothing really too exciting. So let's first of all go ahead and take this emitter and let's move it down to the bottom of this container. So our fire actually has plenty of room to be able to move. Now, one of the things that becomes really important whenever you're using your fluids to make things like fire and things like that, a lot of that look is going to be very, very dependent on your container resolution. Once the resolution starts to go up a little higher, you'll start to see you have a much more defined shapes within your fluids. The thing is, though, that once you take this resolution up really high, it's going to really, really slow down your system. So we're not going to take this resolution up until we absolutely need to. So for now, we're just going to leave this as it is. The boundary Y is one thing that we're going to have to change, because as I play this back, you can see that the fluid rises up, and then once it gets to the top, it sort of mushrooms out, okay, which is typical of a 3D container. I really don't want it to do that, though. I really don't want my fire to be acting like it's inside of an actual container. So let's take this boundary Y and let's take it to negative Y side. And what that'll basically do is just keep this fluid from going and mushrooming out and around. The fluid will pretty much just come to a stop once it reaches the top of this container. Okay, and that's going to be a little bit more of a fire type of a look. But right now, looking at this, we have just this very uniform, no deviation whatsoever as far as this fluid goes. So let's make something that's a little bit more random and a little bit more fire-like. So let's go ahead and start to adjust some of these. And underneath this fluid shape, we'll start off with the density, or I'm sorry, the buoyancy. The buoyancy is pretty much going to control how heavy this fluid is. Now we're going to be dealing with fire, which is much lighter than air. So the higher this number, the lighter this fluid is going to essentially act. So if we were to give this buoyancy something like 8, this fluid should now move upwards much faster. Okay, and you can see that this definitely moves up a lot faster, because by increasing this buoyancy, we've made this fluid light. So it's much lighter than the surrounding air. Okay. Another thing we need to do is let's add a little bit of dissipation and some diffusion. So this dissipation is going to control how long this fluid is going to live. So if we were to give it a dissipation of something like 0.3, let's say, and let's take a look at this. And if we play this back, this fluid is dying off a little bit more. Okay, we might want to give it a little bit more dissipation, maybe something like 0.5, so that it dies off even quicker. So let me go ahead and play this. Okay, and it's sort of hard to see still at this point, but the fluid is actually dying off a little bit faster. We could give it a little bit of diffusion, and some of these changes that I'm making right now will become more apparent here in just a minute when we start to adjust the opacity. Okay, so let's also give this quite a bit of a swirl. Let's say something like 15. And what the swirl will do is pretty much what it says. As this fluid starts to move upwards, it's much more randomized. Okay, and if you look very closely, you can see sort of the randomization that's happening. Right now, though, that's sort of hard to see. So if we take a look underneath the shading attributes, what you'll see is one called opacity. Now if we take this opacity up and adjust this a little bit, you can see this fluid is basically becoming much more dense. Okay, so by adding this swirl, we've added a lot of randomization to this, maybe even too much. So let's maybe try taking this swirl and let's take this back to maybe something like 5. Something a little bit more manageable. Okay, and you can see looking at this, now we have much less turbulence. Okay, let's also take a little bit of turbulence, and let's see. Hey, there's the turbulence. Let's take this turbulence and let's crank this up a little bit so that these flames actually sort of jitter and jump around as they rise up. So let's take this and let's give it a turbulence of something like 0.05. A little bit of turbulence can actually go quite a long ways. So as these flames rise up, they're not going to rise up in quite so uniform of a manner. They're actually going to have a little bit of turbulence and a little bit of differentiation as they rise up, which is really sort of what we want. So you can see now we have something that's behaving much more randomly. Okay, we could increase the frequency and the speed of this. Let's maybe something like 0.8 and 0.4, so this turbulence will pretty much now happen a lot faster. So now we start to kick this up, and this turbulence is going to be happening in a little bit faster kind of manner. So again, something much more flame-like, although we're still definitely a long ways from having something that could be considered a flame. So let's take a look at some of these other attributes that we can adjust. One of the things that we need to be able to do is actually start to add temperature into this whole mix, because right now this incandescence that we have control over, it's going to be controlled by your temperature by default. Now you can set it to a lot of other different things like density, fuel, pressure, speed, but temperature is really going to be what we want to be able to access to get a nice flame type of look. By default though, the temperature is going to be turned off. So let's turn the temperature from off to a dynamic grid. Okay, another thing that we're going to need to be able to adjust is this color. Okay, right now this flame, such as it is going to be using this white color that we have currently selected. But right now though, that's going to be coloring this incandescence. So let's take this white color and let's actually turn it to black. Okay, let's go ahead and play this. And if you look very closely, you can start to see some of this incandescence that's now being set here with this incandescent slider. Okay, let me go ahead and let's take a render of this just really quickly. Okay, and if we look at this, you can see sort of what we got. Now what we've got here is definitely a long ways away from being what you would call a flame. Okay, so what we need to do in the next lesson is let's start to adjust some of these emitter attributes that can give us a little bit more of a flame look. And then we'll go ahead and finish out any adjustments that we need to make with the container itself. In the previous lesson, we began the process of building flames completely from scratch and then exploring the attributes that let you get this type of a look. So what we'll start to do now is focus on adjusting the emitter and then finishing out the flames that we're building. Okay, so in the last lesson, we managed to get something that looked sort of like a flame, but we've still definitely got a long ways to go. So let's go ahead and start off by adjusting this emitter. Okay, so let's select the emitter. Let's go to the attributes for this emitter. And a few things that we can do. Let's first of all, the emitter type by default is going to be set to Omni. So let's go ahead and set this to a volume. By default, it'll be set to a volume cube. Now at any time you could go in, if you wanted to adjust the volume emitter attributes, you have actually a lot of control over what type of a shape this volume is going to be. For us though, a cube is going to work just fine. So I'm going to go ahead and make this cube a little larger and sort of squish it down a little bit so that we have actually now a larger flame that's going to be coming out of here. So if I play this back, you can see now we actually have a bigger flame, or a bigger area that this flame is coming out of. Okay, let's also, while we have this emitter selected, let's go ahead and let's take this density of the fluid emitter. Let's go ahead and take this density up to something like 2 so that we now have something that's a lot more dense that's going to be coming out of this and not something that's quite so airy and gassy looking. Let's also take the heat and the fuel and let's give this a heat value of something like 2. And for the fuel, let's go ahead and give this something a little higher, like 4. Now, we haven't talked about fuels in this emitter or in this container itself yet. So let's go ahead and, before we actually move back to the container, let's turn off this jitter. And that jitter will help us get a little bit more of a steady flame along the bottom. It won't be quite so jumpy and jittery with this turned off. So let's go ahead and select this emitter. Now we have the temperature that we talked about before. We also have within this fuel. Now what you can do with fuel is combine this with the temperature so that you actually get reactions. For example, light or more heat, which can then be used to adjust this color based on temperature. So let's go ahead and before we start to make too many adjustments to this, let's make this flame a little bit more turbulent. So let's go ahead and go back to this emitter and let's adjust the turbulence on this. So let's take the fluid emission. Let's give it a turbulence of about 5. Let's give this a higher speed. So now this emits in a little bit more of a random fashion. So you can see now we have something pretty interesting that's actually starting to happen. We've now got something that's much more dense. So now with the temperature being raised as well, so by adding more heat and more fuel, we're actually now getting more of these colors that we had defined earlier with this incandescence. So if I take a render of this, okay, and here's what we get back. Okay, still definitely a long ways off from being a flame. So let's now start to go in and let's start to add some fuel to this. So by default, the fuel is going to be set to off. So let's give this a dynamic grid and let's go ahead and start to look at some of these fuel attributes. What we can start to do with this fuel is pretty much what I was talking about earlier. We can start to introduce some fuel so that once this temperature gets high enough, the fuel actually will start to combust and then actually can raise the temperature even more. Pretty much like what you would get in real life. So let's go ahead and start things off by giving the fuel scale something a little higher, like 2. And let's go ahead and make this reaction speed. This is going to need to be a lot faster if we want this to look something more like a flame. So let's say the reaction speed something like 0.5. Now with this we can also tell it how much heat do you want to be able to release. Let's say something like 2, and then within this fuel you can tell it also how much light do we want this to actually release when it combusts. So let's say give it a light release of something like 1. Now if we play this back, what we should see is now a lot more heat being generated off of this. So let's go ahead and take a render. Okay, and now you can see we actually have a lot more light and a lot more heat actually coming from within this. Okay, so now we're actually starting to sort of get kind of in the trail of a fire, or something sort of along the lines of fire, although we definitely have still got a long ways to go. So I'm going to go ahead and save this just for comparison. Now let's go ahead and go back to the temperature. And what we can do with this temperature is, what this should be doing is as this fire gets hotter, the temperature should actually be rising up. This hot air should be coming up. So right now the temperature scale, the buoyancy, is set to 3, which means this hot air is moving up. But we can actually give this a little bit of a speed increase. So let's tell the hot air to be moving up a little faster. And let's tell this hot air to dissipate a little faster also. So let's say something like uh, zero point 0.3 maybe. So this hot air can actually dissipate. So I'm going to go ahead and let's play this through and let it do its little simulation. And we'll compare this. Let's go ahead and let me play this back one more time. Try to get it on pretty much the same frame that I was at, just for comparison. Okay, now let me go ahead and render this. Okay, and here's what we get back. And you can see that there is a little bit of difference if I compare the render that we just took to this one. Now you can see what's happening is this hot air is rising up and then starting to dissipate, so we don't have quite as much heat as what we had in this one. You can see this one's actually kind of starting to get a little bit blown out. So by raising this heat buoyancy, or the temperature buoyancy, and making this heat dissipate a little faster, we've now started to get something that's starting to become a little bit more realistic. Okay, so I'm going to go ahead and rewind this. Okay, now I'm going to go ahead and select this fluid container. Now at this point, I'm going to go ahead and start to take this resolution up. Let's say 30 by 30 by 30. Now you can see when I do this that this is going to slow this simulation way, way, way down. So from here on out, anytime I start to play this back, what I'm going to do is go ahead and just pause the recording and let this go ahead and play through its simulation, just so you don't have to sit here and watch this thing play through every time. But for now, we'll go ahead and just watch this and look at the difference. So you can see now I have something that's much more controlled as it's coming up. Just adjusting, or simply adjusting this resolution will actually give you a huge, huge change in the overall look of this flame. So I'm going to go ahead and render this. Okay, and here's what we start to get back. Now what we're actually getting now is something that's not quite so gaseous looking. This is actually starting to now look like it's something a little bit more solid, kind of like a flame, although it's still a little ways away from being a flame. Now what we can do is let's go ahead and start to adjust some of the color on this. Typically on a flame, the brightest parts are sort of around the outside of the flame, and then usually the inner parts of this flame tend to be a little bit darker. Okay, but if we take a look at the color slider, or the incandescent slider that we've got, what this is doing is when we compare this to the temperature, the coolest parts of this are going to be black, and then the hottest parts are going to be sort of a yellow color. Okay, which means right now the outermost parts of this are going to be black. So let's go ahead and actually adjust this the other way. So that way the outermost parts of this have more of that yellow look to it. Sort of like what you would see on a real flame. So if I take this and move it over, let me go ahead and render this, and let's take a look at this. Okay, now looking at this, what we have is definitely now a long, long ways from being a flame. It's kind of a cool look, I guess, but not really what we would be going for. So let me go ahead and let's go back to this incandescence value, and there's actually kind of a nice little trick that you can use to give a nice sort of a realistic flame color to this. What we need to do is let's select this yellow color, okay, and what we'll do is pick something that's sort of a kind of a yellowish orange. Okay, let's go ahead, and once we pick a color that's somewhere sort of in this area, let's go ahead and take this and let's add a value of 1. So let me go ahead and let's first of all just start by zeroing everything out. Okay, let me go ahead and take this back up to sort of a, again, sort of a yellowish orange. The reason I had to zero these out was because some of these still had the same values that I had earlier on, or some of the values that this originally contained. So what we need to do is go ahead and zero these out so that it's pretty much got just, you know, that 1 is the greatest number. So let's go ahead and pick this. And now what I like to do usually is go ahead and actually add 1 to most of these. So 1 is now going to be 2. This is going to be 1.7. And then I'll go ahead and make this one actually 1.6. So this is what I find tends to be a pretty good number to get a nice realistic flame. 2, 1.6, and 1. That seems to work pretty well as far as getting a realistic flame look. So I'm going to go ahead and take a render of this really quickly. Okay, and what we pretty much get back is still not really a flame look, kind of more like a sandstorm really. So let's go ahead and make a few more adjustments to this. One of the things that we could probably do is let's take this temperature scale and let's actually lower this number a little bit so that we actually start to introduce a little bit more of this white color around the outermost parts of this. Let's go ahead and also start to adjust this opacity graph. This is where the real magic really starts to happen. So you can see that we've got around this outer part sort of these real fuzzy edges. It's really not solid looking. So what we could do is let's take this opacity graph and let's take this first little swatch and let's start to pull this kind of over toward the right hand side. Okay, and as we pull this over, you can see how this fuzzy area starts to kind of disappear. So let me go ahead and take this over, maybe just a little bit more. Now the second one, we can actually start to pull over even further. So let's go ahead and take this over a little bit more. And this opacity graph is really sensitive, so you can really start to add a lot of different looks just by playing with this opacity graph. Okay, so I'm going to go ahead and take a quick render of this. Now we should start to have something that's starting to now get more of a flame sort of look to it. Also, while I'm at it, I'm actually going to introduce even some more white into this by just taking this incandescence and pulling it over. So we actually start to have more white around the outer parts of this. So go ahead and render this. Okay, so now finally we start to have something that looks kind of more like a flame. And we were really able to do this pretty much by just altering this opacity graph. And then we needed to actually lower this temperature scale just a little bit more. So what I could do is just to give this a little bit more of a crazy look to it, let's go ahead and add a little bit more swirl. And I'm going to rewind this, and I'm going to go ahead and play this through. Okay, now what I did was just I went ahead and just paused the video, so you didn't have to sit here and watch this play all the way through, which it just took a few seconds. But now if I go ahead and render this, now we've actually started to get something that really kind of does look like a flame. So we pretty much managed to make this flame completely from scratch, and we got to talk about a lot of different attributes in the whole process. So what I want to do is, before I finish off this lesson, I want to go ahead and save what we've got as a fluid preset. So what I can do is just take this preset. Okay, first of all, select the fluid shape, then up under preset, within Maya, you actually have a lot of presets already built, which some of these are really nice. I recommend checking out a few of these. But let's go ahead and save our own fluid shape preset. So let's go ahead and save preset, and it'll ask you, what do you want to be able to name this? Let's call it fire preset, let's say. So let's go ahead and save that. And now, underneath this preset button, we now have a fire preset. Okay, very nice. We could also do the same thing with our emitter if we wanted to. We could go ahead and save this fluid emitter preset. We could call this fire emitter. Go ahead and save that. Okay, and now I have a fire emitter. So now, anytime I make a brand new fluid container, if I wanted to be able to achieve this same exact flame, all I'd have to do is go under my preset, replace the all the settings with this current fire preset, and now with just one click I've got this fire right back the way that we built it. So I'm going to go ahead and show you real quickly just an animated version of the file that we just built. Okay, and here's the fire that we just built in the previous, or in this actual lesson. So you can see that we've actually managed to, within the course of one lesson, completely build this nice fire effect. So we got to talk about a lot of nice attributes and how these attributes actually interact with each other to be able to build this. Now what we'll do in the next lesson is actually take this fire that we built and actually look at how we can use one fluid container to influence another fluid container. So that's what we'll be doing in the next lesson. In this lesson, we'll talk about using one fluid container to influence another fluid container. So the result we want to get is sort of this effect of fire burning along a trail of gasoline. So if you take a look at a rendered sequence of sort of what we're going to be trying to achieve here, we have within one fluid container this trail of gasoline, okay, and then in a completely separate fluid container we have this gasoline that's affecting this fire, so that this fire burns along this trail. Now the reason that we're going to have to use two fluids to achieve this is because the gasoline and then the burning fire obviously have two completely separate fluid attributes. You have this gasoline that needs to be sort of a liquid, more or less, so it needs to remain very, very still, but then you've got this very turbulent fire that's supposed to be burning on top of it, and to achieve both of those effects using one fluid container is probably going to be close to impossible. So that's where we're going to have to use two fluid containers for this. Before we can actually start to link these two completely separate containers together, the first thing we need to do is actually spend some time going over some advanced heat dynamics to actually make this burn correctly. So that's what the first part of this lesson is going to deal with, the heat dynamics of this gasoline trail. Okay, so let's go ahead and start with a new scene. And the first thing I'm going to do is go ahead and make a new 2D container. This 2D container is what's going to contain my actual gasoline. So what I'll do is go ahead and rotate this 90 degrees in the x-axis. And it's important that you rotate this 90 degrees, not negative 90, because we need to make sure that the orientation of the 2D and the 3D container are identical. So whenever we drop in a 3D container, now this 0 and 0 point in the axis will line up. Okay, so very important that we rotate this 90 degrees. So with this container selected, let's go ahead and talk about painting the fluid attributes. So what we can do is, with this container selected, let's go to Fluid Effects, and let's go to Add, Edit Contents, and we'll take a look at the Paint Fluids tool. This Paint Fluids tool is what we'll use to actually paint the gasoline trail. So on the paintable attributes, let's go ahead and change this from Density to Density and Fuel. Okay, the fuel is what will actually cause this gasoline to burn. And it's going to say, do you want to set this to Dynamic? And we'll say, sure, go ahead and set it to Dynamic. Okay, let's go ahead and find a brush size that's pretty suitable. Okay, and now we can go ahead and paint our trail of gasoline. So let's tell it to replace. And now when we paint this, we should now have a trail of gasoline. And if I hit 5 to go to a shaded view, we can see that. Now one thing that you do want to be aware of is that you don't want to paint this trail to where you have areas that touch close together, like this. Because what we'll wind up with is this heat can actually spread. And so as the heat passes through here, your heat might get enough to where it can actually ignite this portion. So let's pull up just a nice wide stroke. Okay, now this, I'm just going to pull this back up real quick and talk about the problem that we have with the heat possibly spreading. If you watch this area of this render, you can see exactly what I'm talking about, where this area just sort of ignites by itself. Well, what causes this area to ignite is that the temperature or the heat amount from this area is actually starting to spread, and it gets close enough to where it can actually ignite this area. So something to be aware of. That's why we're going to make this one fairly spread out so that we can make sure that that heat doesn't accidentally spread. Okay, so something like this, let's say. And with that done, we'll just go ahead and do this. Actually, before we get away from that, we go ahead and take this, and I'll go ahead and add just a smooth operation to this. And this is just to make sure that we smooth out any of these voxels so that we have a nice smooth gasoline trail. So I'll go ahead and take this and just smooth it real quickly. Okay. Now I have just a trail of gasoline. But this gasoline by itself really isn't going to do us much good. You can see if I play this, this gasoline just sort of dissipates, really like a smoke. So we're definitely going to have to do some work to this. What we can do, first of all, is let's go ahead and add into this a emitter. So let me go ahead and add an emitter to this. And this emitter is what we'll use as the actual heat source, the thing that can actually start this ignition itself, that can actually start the flame burning. So you'll want to go ahead and put the emitter pretty close to the area where you actually want this fire to start. So if you want the fire to start here, it'll burn along this way. If you wanted it to start here, the fire would burn along this way. So just sort of up to you which way you want it to burn to decide where you want this emitter to go. So let's go ahead and take a look at the attributes for this. Actually, we want to take a look at the attributes for this gasoline trail first of all. So let's set this up to where it behaves a little better. Go ahead and scroll up. And let's go ahead and first of all set the density type to a static grid. That way we can make sure that this doesn't dissipate like a smoke would. And what we want to do is set the temperature to a dynamic grid. That way this can actually burn the way that we want it to. So let's go ahead and take this emitter. And like I said, this emitter is what we'll actually use as the heat source. So let's first of all maybe key this wherever we want it to start. Key that. And then we'll go a few frames and then key it moving away. Okay, so that way it'll start the ignition and then move back. So let me go ahead and take a look at the attributes for this container. Actually, not the container, the emitter itself. And let's first of all, let's take a look at the heat that we want this to emit. The density and the fuel are both set to 0, and it should be emitting a heat amount of 20, which should be enough to ignite this once we make a few changes to this. And with this fluid container selected, let's take a look at this, and if we play this through, nothing really happens. Okay, the reason for this is because we have this white color that's pretty much overriding anything that we can see. So what we need to do is, underneath the color area, let's take this white color and let's set it to something like a dark gray. Okay, now once this is set to a dark gray, immediately we can see that something has changed. Okay, now we can actually see some of the incandescence that's being controlled by the temperature itself. So now we're actually seeing temperature as this is happening. So let me rewind this and play it through. And if we look closely, you can see that there was a little bit of a burst of fire in this area, so it got really hot, but then it just cooled off. Okay, and now this heat's just sort of spreading in a pretty nonsensical fashion. Okay, just kind of chaotic at this point. So what we need to do is set it up to where this fluid can actually burn along this entire length. So what we need to do for this is take a look at the temperature of this gasoline. And let's set the temperature dissipation to 0. So that way this temperature doesn't just start to disappear. Let's also take a look at the fuel of this, which is the actual substance that's causing this burning to happen. And let's go ahead and take the reaction speed to something like 1 so that this burns much faster. And let's take the heat released up to something like 2, so that way more heat will allow this to burn faster. So playing this through, okay, that's starting to behave a little better. Now when we rewind this and play, now this heat is actually staying attached to this quite a bit better. Although it still does need a little bit of work. Still doesn't quite behave like we need it to. So what we could do is take a look back at some of these temperature settings and some of the density settings as well. So let's go ahead and let's take the density buoyancy to 0, so that way it stays put a little bit better. And let's take the temperature turbulence, and we'll make sure that that stays set to 0, so that way this temperature doesn't fluctuate too badly as this moves along. Okay, let's also take the temperature diffusion to 1, which is pretty much where it needs to be. Fuel scale looks pretty good. We might even take this reaction speed up a little bit higher, because as we play this through, this still burns pretty slowly. So let's maybe see what happens when we take this reaction speed even up a little bit higher. And this ignition temperature right now is set to 0, so that you can see it sort of spreads in a little bit of a chaotic fashion. So if we raise this ignition temperature just a little bit and play this through, now it has to have a certain amount of heat before it actually ignites. So there we go. Now we actually have something that burns along this trail the way we want it to, and it's able to actually very realistically simulate the way that heat would spread along a trail of gasoline. So in the next lesson, we'll actually start to look at how we can use an expression to link the attributes and the burning motion of this 2D container into the fire effect that we created in the previous lesson. So that's what we'll do next. In the previous lesson, we were able to create the dynamics for the burning gasoline within a 2D container. So in this lesson, what we'll focus on doing is building an expression to have the gasoline control the emission of fire inside of another container. So let's take a look at where we left off, and if we play this back, you can see the dynamic for the burning gasoline that we were able to build in the previous lesson. So let's go ahead and now add into this scene our fire container. So let's go ahead and move this up, and these containers really don't need to be sitting directly on top of each other. For visualization, we could actually just move this over to the side, but what I'll do with this is go ahead and apply this fire preset that we built earlier in this training kit. So I'll go ahead and just apply the fire preset to this. Okay, now here's kind of the basis of what we'll be doing with this expression. Now each one of these containers is actually made up of voxels. So what we'll do with this expression is basically just say, okay, in voxel number 1, let's go ahead and check if the heat is existent. If there is no heat, move on. Check voxel 2. If there's no heat, move on. Check voxel 3. If there is heat in that voxel, go ahead and ignite the corresponding voxel in this container. So what we're pretty much just going to do is write an expression that says if there is a certain amount of heat and a certain amount of density in this particular voxel, one that's sitting right here, go ahead and ignite that corresponding voxel in this container. That's pretty much what the basis of this expression is going to be doing. Now, since we're going to be checking this on a per voxel basis, we need to make sure that the resolution for this gasoline and this fire are set to the same number. So looking at this, this gasoline has a resolution of 40 by 40. this fire has a resolution of 30 by 30. So you need to make a choice. Do you want to take this container up to 40 or take this one down to 30? Whichever choice you make really doesn't matter so much. So we'll go ahead and take this one up to 40. Okay, now let's go ahead and actually focus on the expression itself. So just to make this a little bit easier to name in our expression, rather than having to name these fluid 1 and fluid 2, we'll just call this one gas, and we'll call this one fire. There we go. So now with these in our scene, we can now start to build the expression itself. Okay, so jumping back to Notepad, we'll go ahead and start to make this, and we'll start this off by making a couple of variables. We'll make a float variable, and we'll call this variable, we'll call it resolution y. Or I'm sorry, let's just go ahead and start with resolution x. Okay, and this resolution x will be gas resolution width. Okay, so the width of the gasoline container. We'll make another float variable, and we'll call this one resolution y. And this one is going to be the gas resolution height. Okay, so the x and the y resolution variables that we're going to go ahead and use are referring to the height and width of this gas container. Okay, that's pretty much what we've told the expression to do so far. Okay, let's go ahead and space this down. And let's go ahead and make an integer, or in other words, a whole number. And this one, we'll call it row. And we'll make another one, another integer, that's called column. Okay, so row and column, which is going to refer to the rows and the columns, or the x and y voxels of this particular container. Okay, so now let's actually make the expression itself that will tell it, okay, go ahead and check each one of these voxels and compare that to the voxel over here. So if we have a certain amount of heat in this voxel, go ahead and ignite the corresponding voxel over in this guy. So I'll go ahead and just comment this out, just so if I hand this off to somebody else, they'll know kind of what I'm going at here. Okay, so we'll tell it to go ahead and just loop through the rows and columns. So let's make a for loop to make this happen. And I'll go ahead and just sort of type this out, and then once I'm done, I'll sort of explain what this is actually going to be doing. So we'll tell this to make the row. We'll go ahead and say that's going to be 0. And then let's say when the rows are going to be less than the variable of resolution x, then go ahead and let's take that row variable and we'll go ahead and just add to itself. Okay, so what we said basically is we've told this row variable to be set at 0. Okay, so what that basically tells it is 0 is going to be down in this corner. So that's where the row starts, down at 0. And then we've said, okay, as long as this row is less than resolution x, which is 40, because that's what we set the resolution to, So it says as long as you're less than 40, then go ahead and keep checking until you hit 40. Then you know you're done. So it's going to go through and check 40 times along this row, and then it knows it's done. So that way it knows it's hit every one of these voxels. Now let's go ahead and tell it to do the same thing for the columns. So let's say within another for loop, let's tell it to take this variable for the columns, and we'll make that 0 also. So that way, again, it'll start down in this lower corner. And we'll say that as long as that column is going to be less than the resolution of y, then go ahead and keep adding to yourself. Go ahead and close all this off. Make sure we close all these loops. So here's what this pretty much says. We say the rows and the columns are both going to be 0. So 0 and 0 on this little fluid container is right in this lower corner where these two corners meet. So we say, okay, 0 and 0, that's where you're going to start. So as long as you're going to be less than the resolution of x and y, which is 40, then go ahead and keep moving along these rows to check for whatever we're about to tell it to check to. So just say, okay, go ahead and keep going. Once you hit 40, you're done. Now in the next lesson, we'll actually talk about what we're actually going to make these check for, and actually finishing up this expression. In the previous lesson, we began to write the expression that can link two separate fluid containers and allow one container to influence the other one. So what we'll do in this lesson is continue to write that expression. Okay, so in the previous lesson, we began to write the expression that lets us pretty much say each and every one of these voxels, check it, and then go ahead and check that against the corresponding voxel on this other container. So let's go ahead and keep writing that. And what we did in the previous lesson was pretty much just write the expression that lets it check the different rows and the different columns of this container. Now we need to tell it what to be checking for. So what we'll do is within this same loop, let's go ahead and add a new line. And what we'll do is add in a new float variable. Okay. Now this float variable, we can call it pretty much anything we want, but I'll call it heat. Okay, and I'll make a quick array here. Okay. Now within this array, we're going to tell it to get the temperature of this particular voxel. Now let me go ahead, and just so that it's a little easier to see, I'm going to select this fluid container, and underneath the display properties, let's change this to full. So that way you can actually see the voxels and actually visualize this a little better. So what we'll tell it to do is, first of all, at each particular voxel, we want it to gather the temperature, and we want it to gather the density. Okay, and then we can say if that temperature and density is greater than a certain amount, then go ahead and ignite the corresponding voxel over on this side. And that's pretty much what we're going to do with this expression. So let's tell it in this heat to, let's go ahead and tell it to get a fluid attribute, get fluid adder. Okay, and now we can tell it what do we want it to get. So let's tell it to get the attribute temperature. And now we'll tell it where to apply it. So we'll go ahead and tell it to give it the x index, of whatever it happens to be uh, set at, or whatever row it happens to be on at the time. We'll tell it to do the y-index of whatever column it happens to be on. And then we'll tell it to take that attribute from the gas container. Okay, go ahead and end this. Now it's sort of spread down below one line, but this is all just really one line. So we've told it to go ahead and get the temperature attribute from whatever row and whatever column it happens to be on in this gas container. So I'm going to go ahead and add another float, because there's one more attribute that I want it to gather, and that is the density. So I'll make one more. So I'll call this one gas density. And I'll go ahead and make an array for this. And we'll tell it within this array that we want it to get the density. So let's get fluid adder, and we're going to grab the attribute density. Okay, and then we can tell it where we want to get that density from. So let's tell it to get the x-index for whatever row it happens to be on, and the y-index for whatever column it happens to be on. Okay, and we'll tell it to take it from the gas container. Okay. So what we basically told it to do is for each one of the 40 rows and the 40 columns, then what I want you to do is at each one of those voxels, I want you to check to see what the temperature is, and I want you to check to see what the density is. Okay, so that's pretty much what we've told it to do. Okay, now we need to tell it what to do with the density and the heat once it finds a certain temperature. So I'm going to make another if loop, and this is where we can actually tell it what we want it to do. So let's say within this if loop, this heat attribute that we were talking about earlier, so we've told it to, within this, take a look at what the temperature is going to be. So we can say within this array, we can tell it if this heat is anything greater than 0, then let's go ahead and type this in real quick. This gas density. We'll make this array here, and we'll say if that's greater than 0, okay, so this little line here says if the heat is greater than 0 and if the gas density is greater than 0. That's what those two little symbols mean, these two little and signs. It's if the heat and the gas density are both greater than 0. So if the heat's greater than 0, but the gas is still 0, then nothing will happen. But if they're both greater than 0, then you can actually get your result. That's where these two little guys come in, because we want to make absolutely sure that both the heat and the density are at a certain amount before we ignite the certain voxel over on this other side. That's why this becomes very important. So now we need to tell it what to do. So let's go ahead and add into this loop. Let's tell it when it comes across these certain circumstances, let's set fluid attribute, and let's tell it to set the attribute of density ahead and let's tell it to set the X index to whatever row it happens to be on. We'll tell it to set the Y index to 0. Okay, I'm going to set the Y index to 0 so that way I can make sure that it actually ignites at the bottom of this 3D container. When the fire actually comes up, it'll ignite at the bottom of this Y-axis. In other words, 0. So we'll make the Y-axis 0, or the Y-index 0. Now, we're going to be dealing with the actual 3D container now, so now we have a Z-index to deal with, and we'll tell the Z-index to be whatever column you happen to be at on the 2D container, and then we'll tell it to add a float value of 1 to the fire fluid container. Okay, so if the heat is greater than 0 and if the gas density is greater than 0 on a certain voxel on this 2D container, then go ahead and set the fluid attribute of density to a certain amount on this particular voxel over here. And that's kind of what we're doing. So let me go ahead and tell it to add a few more things. So let's tell it to go ahead and also set a fluid attribute. And we'll tell it to add the attribute of density, or not density, fuel. And we'll tell it to, again, be the X index of whatever row, whatever Y index of 0, and the Z index of the column. So rather than having to retype all that in, I'm just going to use that all over. So attribute fuel, X index, whatever row you're on, Y index 0, so that it winds up at the bottom of the container, and a Z index of whatever column you happen to be at. And we'll tell it to add a float value of 4 to the fire fluid container. And we'll add one more thing. Let's tell it to set a fluid attribute. And now let's tell it to add the attribute of temperature. Can't spell today. Temperature. There we go. And pretty much the same thing. Whatever the X index, whatever row you're on, Y index, whatever column you're on, or Y index of 0, and a Z index of whatever column you're on. And we'll tell it to add a float value of 2 to the fire container. Okay, so if the heat and the gas density is greater than 0, then go ahead and add density, fuel, and temperature to this fire container. And that's pretty much what this expression is going to do for us. I also need to, I believe, close off this one last loop. Okay. Now, this is pretty much what our expression's doing. Now we've actually set up all of the things. We've told it to check all of these different voxels. We've told it what to look for when it checks these voxels, which is the density and the temperature of each one of these. And now we've told it if the density and the temperature are both within a certain amount, then go ahead and add fuel, density, and temperature to that corresponding voxel on this fluid container. That's how we can actually use an expression to link these two fluid containers together. So in the next lesson, we'll actually take this expression and put it to use. Now that we have the expression built that will allow the fire to burn along this gasoline path, now we can actually take that expression and then plug it back into Maya. So let's go ahead and open up Maya, and we'll take a look back at Notepad. And all I've done since the last lesson was I went ahead and just made this font a little bit smaller so that this all fits on one line. You can kind of see exactly what I was actually typing in the last lesson. I've also included this expression on the training kit itself. Now, one thing I should probably mention that I think I forgot to mention in the last lesson is you really need to be careful with these little quote marks that are at the end of these two lines in the expression. Okay, these little quote marks are actually very, very important. Now, it looks like these are just the little quote marks that are next to the enter key on your keyboard, the little single quotes. But these actually aren't. These are the little, what's called a back quote. The back quote is actually found on the tilde key next to the number 1 on your keyboard. So very important that you use the back quote that's on that tilde key and not the single quote that's on your keyboard, or that's next to the enter key on your keyboard when you're making this. Otherwise, the expression is not going to work correctly. So with that in mind, let's go ahead, copy this, and I'll paste this back into Maya. So I'll just go ahead and go to the expression editor. And we don't have to select anything. There's really nothing in particular that we're going to be applying this expression to. So we can just go ahead, select this, paste it all back in, create it, and no errors came back. So it looks like everything works correctly. Now let's see if this is going to work. So we play this back, and we let this do its thing, and now we can see, okay, now that there's a certain amount of temperature in this area, it's going to ignite the corresponding voxel over here. Now we do actually have a pretty serious problem, and you can see that this fire is actually happening a lot faster than what this gasoline trail is burning along. So let's see what we can do to fix that. Let me go ahead and stop this. And you can see it is burning along this trail like we want it to, but it's burning quite a ways ahead of this actual gasoline. So what's going on here? What's causing that? Well, the problem is that we've told it in this expression, if the heat and the density of this little container here, if that is greater than 0, then go ahead and ignite this container over here. So anything greater than 0, maybe 0 is not such a great number. Let's maybe say if the heat and the density are greater than maybe 0.2, let's say. Maybe that'll give it a little bit better number to actually work with. So it's actually got to get hot to a certain point before it can actually ignite. So let's try that. Let's go ahead and go back to the expression editor. Okay, let's try that. Okay, I'll rewind this. Let's see if that behaves any better. Now that we've told it that this actually has to get to a certain heat before it can ignite over here. Let's see if this behaves any better. So I'll give this just a second to play through. And you can see that this expression definitely slows down the system, because for each and every frame, it's checking every single one of these voxels to see if there is the correct amount of heat and density. And any place that it finds the correct amount of heat and density, it'll go ahead and ignite the corresponding voxel over here on this container. Now, you can definitely see that this is running a lot better. This fire is not jumping out ahead of the gasoline anymore. So I'm going to go ahead and stop the playback on this. Okay. Now, I'm going to pause this for just a minute because the system is running pretty slow now. I'm going to pause this for just a second and let you see what we've got as this plays through further. Okay, so I've gone ahead and just let this simulate through a little further, and you can see that we do have a few problems with this. One of the main problems is that these flames are now definitely way too tall. So we're going to have to find a way to fix that. And number two, you can see that these flames are definitely a little bit darker than what we had originally set these a few lessons back. Now this container is using just that fire preset that we built earlier. So it's using the exact same settings that we had set earlier. The problem is, though, that now, because we're using a greater heat source to actually ignite this fire preset, a few of these settings are now just a little bit off. So one of the things that we're going to need to do is let's go ahead and take a look at the temperature. Okay, the temperature scale right now is set to 0.8, which is what we set it to in this preset. We'll come back to this one though. What we probably need to do is go up to the density, and let's start by actually lowering some of these numbers a little bit. You can see one of the things that this flame is doing is it's not quite as solid as the other one that we had. So again, this is because the higher fuel, or the higher temperature that this is burning off of, has kind of adjusted some of these settings that we had. So what we probably need to do is, one thing that we could do to fix that, so let's take this density dissipation, let's set that to 0, and everything else pretty much is set correctly. Now, the reason that this flame is reaching up so high is because this temperature is so high. It's keeping this temperature a lot longer than it should. So let's go ahead and set this temperature dissipation. The dissipation we want to set quite a bit higher so that this dies off a lot sooner. So this temperature dissipation, let's try something like 0.05. Okay, the diffusion, we'll go ahead and set this to 0, again, to sort of keep these flames a little hotter as they reach up toward the surface, because you can also see these flames are a lot darker. So if I render what we've got just so far, this is what actually comes back, which might be kind of cool, because I mean it does look like there's just a really, really thick black smoke that's coming off of this, which if you wanted to achieve that sort of a look, this is how you could do it with just one fluid container. Now, what's actually causing this dark area up here? Why is this happening? This is being caused really by the temperature scale. Now, the temperature scale is going to control how much temperature is spread out through here. So if we were to set this to a lot lower number, maybe something like 0.15, we should have this flame be a lot lighter now. And you can see now that it is. So let me go ahead and rewind this. And now that we've made these changes, we should now have a much more manageable flame. So I'm going to pause this for just a minute. Okay, so now playing this through, you can see, yes, the flames are definitely a lighter color, but now the flames are even worse than they were. I mean, now I've got just this inferno going on within my scene. So what I probably need to do is, let's take this density, and I believe I'd set it to 0, which it probably doesn't need to definitely be that low. That density dissipation is what's causing this to last forever and ever and ever. So let's try something like 3 as the density dissipation, and let's see what that does for us. So now these flames are a lot more manageable. Now we've set the density dissipation up quite a bit higher. Now these die off a lot sooner after they burn away, and then by just lowering the temperature scale, we've now managed to get some of these original colors back. But I'm going to go ahead and take a render of this just to see what we have, and what we'll probably see is that these fluids, or this fire, is probably a little bit blown out. There's probably going to be a little bit too much white in these flames. So yeah, the flames probably do have just a little bit too much white in these, but luckily that's real easy to fix. We can just go back to the shading in the incandescence, and let's just take this white slider back down. Originally, when we built this fire, we weren't working from nearly as hot of a heat source, so we were able to take this incandescence further over. But by lowering this, now this should be a lot more manageable. So let me go ahead, and while I have this selected, let's take these flames, and under the shading quality, let's set the render interpolation to smooth. And we'll go ahead and give this a higher shading quality. And I'll also do the same thing on this gasoline. So I'll take that up to smooth, give this a higher quality. And now to just sort of complete this illusion, we'll go ahead and line these two containers back up. I'll go ahead and make sure that these sit pretty much directly on top of each other. And now that sort of completes this whole illusion. We have the appearance of fire truly burning along this gasoline trail, which in a sense it really is, but we're just using this gasoline fluid container to control the flames in this 3D container. So, and then if we wanted to go back and adjust maybe the coloring of this fluid so that maybe you have some blue along the hottest part of this flame, you could always go in, and probably an easy way to do that would be to just add a new color swatch right here, which will maintain whatever color you've got. And then let's maybe try to just add maybe a little bit of blue into this. So let's see what that looks like. So now we actually have some of that blue color along the base of these flames, which is really kind of what you would get if you were going to be burning along something like gasoline or a really significant fuel source. You're probably going to have the hottest part of your flame have this blue color. So let me take a look at what this would actually look like when we render this out. Okay, and here's the rendered version of what we pretty much just built. So we have the fire that burns along our flame and burns quite nicely. So we've got now these two completely separate fluid containers that are being controlled by each other. So again, that's how we can use the expressions to actually make this happen. For the next few lessons, we'll begin looking into some of the tools and the features of Maya Fluids that we can use to realistically simulate a real boat moving across the water and also kicking up particles, as well as being able to leave a boat wake behind. Now there's a lot of different attributes of Maya Fluids that we're going to have to be able to get to work in conjunction with each other in order to really be able to pull this off. So lots of stuff that we're going to have to talk about. What I've got so far in this scene is just a simple paddle boat that's sitting out in the middle of the ocean. Okay, and so far I just have a quick little bit of animation on this boat that just lets it move along. So there it goes. Okay, and you can see that this boat's actually pretty large if you look at the size of this boat compared to my actual grid within Maya. So the reason for that this is such a large scene is because when I get to the point where I start to have to use wake emitters to actually start to kick up this foam, those wake emitters are going to have to be pretty large in order to be able to kick up the amount of foam that we need. So that's why this scene is so large. Now, the scale and the size of everything in your scenes, especially whenever you get to the wakes, is going to become really, really, really important. So, just for example, if you take a look at the scale that I'm using right now, it's about 2.3. Okay, pretty close to that. If your scale is anything a lot more or a lot less than that, then the numbers that you're going to put in are going to be a lot different. Okay, and that's really the thing that you're going to have to be aware of whenever working with especially wakes and wake emitters, is that the overall size of the wake emitter really, really, really influences the number that you're going to put into those to actually make the wake occur. So let's go ahead and start by actually adding the wakes themselves onto this boat. So what I can do is select all these paddles that I actually want the boat to be applied to. So select all the paddles, and you'll want to make sure that you go ahead and freeze the transformations on this. So let's go ahead and freeze the transformations on this geometry. Okay, and that way we can go ahead and make sure that we remove all of the scaling on this, because otherwise, if we don't do that, the wake emitters are going to come in attached to these paddles just like we want, but the wake emitters are going to be scaled really, really, really thin because they're going to be using the scale that these already had. And consequently, you won't get many particles out of those wake emitters. So we'll freeze the transformations to zero everything out. And with all these selected, let's go to Fluid Effect, and let's go to Ocean, and we'll tell it to create a wake. Now in this wake emitter option, in addition to be able to giving it a wake and wake intensity, we also want to be able to add some foam emission to these wake emitters. So that way these can actually kick up foam as these are moving. So I'm going to go ahead and set mine to about 2.4. So we'll create an ocean wake. Okay, really doesn't look like much happened. That's because it goes ahead and it'll put everything right here at the center. Now there's a few options, or there's a few boxes here that it'll go ahead and add in here as well. One of those, if you take a look at it, is the fluid texture. And if we go to the attributes, we can actually see that's the wake texture. But if we move this, we can see there's actually another box here as well. This is the ocean wake foam. So whenever moving these, you want to make sure that you actually grab both of these at the same time. So we'll go ahead and scale this up. And what you want to do is take these and scale them to the point where they completely surround the boat. So go ahead and make sure that your boat never moves outside of these boundaries or outside of these boxes. Go ahead and skip forward a few frames. Okay, so that looks like it pretty much stays inside of these boxes. Now outside of these boxes you won't get any foam or any wake that's being kicked off of these, so that's why it's important to make sure that that surrounds your boat. Also, one thing to be aware of is you want to make sure that you don't try to scale this to fit inside of your boat, because your texture is dependent on the size of this. So what you'll get are these really nasty squished foam textures. So want to make sure you keep that the way it is. Okay, and here's the wake emitters that this actually put down for us. And you can see here's the different wake emitters that it's placed out. So I'll go ahead and just really quickly sort of split these apart, make sure we've got all the ones that we need. Okay. So now we can select one of these. And the reason I had to space these apart is because right now they're all sitting on top of each other. So as I select now each one of these paddles, you can see the wake that was supposed to be assigned to it. So with this selected and the paddle, let's go to field, and let's tell this wake to use the selected source as the field, and that'll go ahead and snap it back up to that paddle. Okay, I'll go ahead and do that for all the rest of these. Go ahead and just snap all of those. Keep going until we get all of these. Get this one, get this little guy over here, and grab this one. Get down underneath here, grab that one. And last one. Okay, so now we have all the wake emitters attached to these paddles. And what we should see is as these paddles move, the wake emitter will go ahead and stay attached to that. Now one thing I will do really quickly, we go ahead and just turn dynamics on so I can select all of these. I'm going to go ahead and actually add my shelf into this scene. And what I want to go ahead and do is make it a little bit easier for me to be able to select these again. So let me go ahead and just clear my history out of my script editor, minimize this, and what I'll do is go in and just grab each one of these wake emitters. Okay, so with all those selected, now if I go ahead and open up my script editor, it went ahead and recorded me selecting all of these. So what I want to do is actually take this little bit of code and I'll just take this up to my shelf. So just middle click, drag it up, and now anytime I want to select these, I could just click on that little mailbox and easily select all my wake emitters. Because right now those get to be pretty hard to select with those being right in the middle of all these paddles. So that's how we can go ahead and get the base of this set up. So in the next lesson, we'll go ahead and talk about all the attributes that we're going to need to set up to really make a lot of these things happen in conjunction with each other. Now that we have the wake emitters set up on the paddles, we can go ahead and actually start to adjust some of these attributes so that we can get the looks that we really need to achieve a level of realism. So let's go ahead and take a look at what we've got. And just taking a look at where we left off from the last lesson, if I let this go ahead and play through, let's see what we've got at this point if we try and render this. Hey, we really don't have much of anything at all. Okay, you can, if you look real closely, you can sort of see a little bit of a splash and a little bit of a ripple right here, but other than that, really not much. So let's take a look at what we need to be able to do to really make this foam start to happen. So I'm going to go ahead and select these wake emitters, and one of the first things I want to do is scale these out to where they pretty much cover up the entire paddle, because really we want the entire paddle to be kicking up foam, not just this centerpiece of the paddle. So we'll go ahead and select all those. Now with all those selected, we'll go ahead and open up the attribute spreadsheet. So let's go to the general editors, and we'll go to the attribute spreadsheet, and this will just save us the trouble of having to go in and adjust all of these different wakes one at a time, because that will really get pretty tedious. So with this, we'll select all these. We'll go down here to the very end, and we'll take a look at the heat density, the fluid heat, and the fluid fuel emission. So let's go ahead and take the fluid heat and the fluid fuel, sorry, getting a little tongue-tied here, and we'll take both of these and let's try setting these to something like 20. So that way we can generate a lot of heat and get a lot of fuel out of this. And those two are what will actually generate this white foam as this moves along. So let's also give this a little higher density, maybe something like 10, so we can get a little better waves coming off this. Actually, I'd go ahead and maybe leave this at something like 5. Maybe just leave this down at a little lower number for now. Okay, so I can go ahead and rewind this, let it play through. Give it just a second here. And let's take a look at what we've done. Okay, so by adding more heat and more fuel to these wake emitters, now we're actually kicking up foam and actually sort of leaving a white foam trail as this paddle boat passes along. Okay, but one thing that you can probably see is that this long foam trail is probably dying off way too fast. For something like this, like a paddle boat, that's really going to be disturbing the water as it passes through, it's probably going to leave quite a bit longer trail. Okay, so let's look at how we can actually get this to last a lot longer. What we need to do is let's go to the attributes, and what you want to select is the ocean wake foam texture. Okay, and again, that's one of these boxes. And what we can do is let's go ahead and come down here to the temperature. Now the temperature scale, let's go ahead and maybe take this up just a little bit so that we have a little bit stronger foam. Now the thing that we can really do to make this trail last a lot longer is let's lower the dissipation and the diffusion. So the dissipation will actually cause this to die out and get cooler faster, so a lower number will cause that heat to stay in there longer and leave you a longer trail. The diffusion is actually what will cause this to spread out over time. So this heat will spread, and so you get this much wider trail. So if we compare the diffusion at 0.8, go ahead and let this play through really quickly. We'll do a quick comparison of what the diffusion looks like at this number compared to a lower number. So let me let this play. And let's do a quick comparison. So you can see, looking at this, now by lowering that temperature diffusion, now or by lowering the temperature dissipation, we've actually managed to make this trail last a lot longer because this heat is staying in here and able to maintain this. So this is what the diffusion looks like right now, and it's probably definitely spreading out quite a bit further than what we would want. So let me go ahead and close this. And let's take a look at what the diffusion looks like at a much lower level. So let's try something like 0.001. Now that should hopefully let this trail stay a lot closer together as this passes through, so we don't wind up with a large, real spread out wake that's coming off the back of this. So let's compare what that looks like. And now you can see that this foam, or this trail that it's leaving behind, actually stays much closer together. It's not nearly as spread out over in this area as it was earlier. And again, that's being controlled by this diffusion, which is set to a pretty low level right now. So let's also try and give this a little bit of turbulence, just to sort of help stir things up a little bit. So let me give it a turbulence strength, maybe just a little bit lower than what it is now, so that way we don't have quite so many of these fingers and whatnot that are coming out of this, because you can see how it's pretty striated in this area. You get these pretty defined areas, so maybe by taking out this turbulence, we can help cut down on some of that. So let's also take this turbulence frequency, maybe give it a higher number of 0.5. Okay, looks pretty good. Now let's take a look at what attributes that we probably need to adjust within this actual ocean wake itself. Not the texture, but the actual wake. Okay, this ocean wake is what's going to be controlling the look of these ripples as they come out from behind this boat. So definitely you can see that these ripples are not probably what they should be. It literally looks more like somebody's just dropping a rock into the water at this point, rather than just paddles that are kicking this up. So let me go ahead and select those, this wake texture. Okay, and while I've got this turbulence open, I'm going to go ahead and give this a little bit of turbulence, just so that these wakes, or these actual ripples that are coming off, actually have a little bit of turbulence to them. So let me give this a turbulence strength of something like 2. Maybe give it a frequency a little bit higher. And the speed, I think I'll go ahead and leave that as it is. So let's take a look at some of these density attributes, and that's what we can use to control how these ripples are going to be looking. So this density scale, let's go ahead and lower this buoyancy a little bit, just so that these ripples aren't quite so defined. And the dissipation and the diffusion, let's give these a pretty high number, so that way these ripples won't continue to carry on for a long distance. If there are any ripples, they'll stay really close to this area. That's what we can do with the dissipation and the diffusion. So if I play this through and let this do its thing, what we should see is ripples that are not nearly as pronounced as what we had before. So if I take a render of this real quick, okay, now you can see that the ripples are much closer to this actual paddle, but you can see it's also done something else. By lowering these ripples, we've definitely lowered the amount that these ripples are disturbing this foam that it's leaving behind. So now we have a what almost looks like a solid surface that's back behind here. So we'll probably have to go back to these wake emitters and probably turn down the amount of heat and the amount of fuel that these are pushing out, because this is definitely overkill what we've got at this point. So we'll come back and fix that definitely at a later point in time. So one thing that we probably also need to do is let's go ahead and give this overall ocean shader just a little bit of foam overall. So let's go down to the ocean attributes, and by default the foam emission of this ocean is going to be set to 0. So let's go ahead and give this just a little bit of foam emission overall. Okay. So we've gone ahead and managed to talk about most of the attributes that we can use to adjust the way that this foam looks, and sort of how we can get sort of these different attributes to interact with each other, and the way that they control each other, which is something that's really important to understand if you really want to be able to recreate something like this on your own with different scales and different sizing. So something to definitely be aware of. And in the next lesson, we'll go ahead and start to add some more realism to this by setting up a system that will let us add particles into this scene and actually have particles and mist that are being kicked up by these wake emitters. Now that we have the wake and the foam set up the way we want, we can now start to go into this scene and add some particles so that these paddles of the paddle boat can actually kick up some foam and some mist as these are turning around. So here's where we left off in the last lesson. And before I forget, I want to go ahead and just make a few adjustments to these wake emitters so that we can try and get rid of this sort of long trail of foam that we had before, this really thick trail of foam. So before I forget, I probably want to go ahead and fix that. So I can go ahead and select these. Let me go up back to my attribute spreadsheet, and let's go down toward the end. And there's a few things that I want to look at. Really the one that I want to find is this, it's fluid drop-off shape, okay, which is this right here. This fluid drop-off, if we take this up, we can sort of help to stifle some of this heat that's coming off of here and sort of help that drop away faster. So if I let this render through, we can go ahead and let this do its thing. We go ahead and minimize this. And by increasing the fluid drop-off rather than lowering the amount of heat or fuel that this is putting out, can just help to ensure that I don't have to go back and adjust too many attributes. So your fluid drop-off shape is really kind of a nice way of being able to control that. And you can see now that we definitely have something that's not quite as intense as it was before. So if I wanted to, I could go ahead and open this back up and maybe give this a little bit of turbulence. So let's say I wanted to take these wake emitters and maybe set this turbulence to, oh, I don't know, something like 2, maybe, just so that these are able to actually kick up a little bit of disturbance as these actually move. The turbulence frequency, I'll go ahead and keep that as it is. The turbulence speed, and maybe I'll boost that up just a little bit, maybe something like 1. Let this thing play through, and we should see something that looks, you know, a little bit more natural now. And if we need to, we could probably even increase this fluid drop-off a little bit more if we need to actually get a little less foam. Okay, so now we have a nice little bit of foam that's actually got a little bit of disturbance in it and is looking to be pretty nice. I'd probably need to go back and adjust maybe this dissipation, because now this trail probably is a little bit too long. But we'll go ahead and fix that later. What I really want to do now is start to go in and add some particles into this. Now there's a few ways you could probably go about doing it. We probably could write a pretty extensive expression that could allow particles to be generated whenever these emitters collide with the surface. That's one way you could do it, but there are easier ways that we could do this. Specifically, I'm going to go ahead and let's just make a polygon plane. And what we can do with this is I'll just use this plane as an emission for particles. So I'll go ahead and get this set up. Let me scale this so that it fits over the entire paddle, and scale this out just a little bit. Okay, maybe move this in a little bit more. And again, what we'll do is we'll actually make this plane emit particles. And then we can say whenever the paddle comes in contact with the particle, go ahead and just kick that up. So with this selected, let's go ahead and underneath the fields, or I'm sorry, underneath the particles, let's tell this to emit from object. So as I play this through, you can see it's being emitted from the object. Okay, let's go ahead and go to the attributes for this, and let's tell this emitter to emit from the surface. And that way it emits a little bit more like it should. Now we're definitely going to need a lot more particles than what we've got here. So let's try taking this up to something like 1,000. Okay, now we've actually got a lot more foam that's going to be generated. So these will actually be what we use as the foam. Okay, so let me go ahead and go to the outliner of this. And what I can do is just take this particle plane and we'll drop this up into the boat group. So that way this plane can actually move along with the boat itself as it moves, and it's leaving these particles behind. Definitely, though, not what we would want to happen as far as just leaving these particles behind. So let's go ahead and play this through for just a second. And let's select this particle, first of all. And now we can just select the actual paddle itself, and we can tell this particle to go ahead and make it collide. Okay, and what I'll do is go ahead and just do that with all the rest of these paddles. Not the emitter itself, just the paddles. So you'll want to make sure that you don't accidentally select the emitter, or this wake emitter. So we'll go ahead and tell it to collide. Do that again. Do it with this one. Grab this one. That one, and I believe we have one more. So there we go. So now when I play this through, we now have some particles that are being kicked up by these paddles. Definitely have a problem though, because you can see these particles that are being kicked up, they just keep going. These things are being shot up into the stratosphere right now. So we're definitely going to have to find some way to bring these back down. So let's go ahead and add maybe a little bit of gravity to actually start to pull these down. So let's go ahead and play this through for just a second so we can watch this. And let's add into this a gravity field. So we'll go ahead and add gravity. And you can see there's my gravity field right there. So let's play this through. And now these are being pulled back down a little bit more. If we look, you can see those are being kicked up. Okay, so not bad. Let's go ahead and play this through. We actually maybe just rewind this and pull this up just a little bit. Okay. So let me go back to this gravity field while we're at it. Okay, so there's the gravity field. Now these are definitely not behaving quite the way they should. So let's take this gravity field and let's tell it to pull these down a little bit harder. Let's see what happens if we give this a magnitude of something like 1,000. Okay, now these are coming down way too fast. So let's say maybe something like 10. Maybe 20. Okay, so that's behaving now a little bit better. Now I don't want to crank this value up too high because I don't want these particles to come down unnaturally fast. But you can see that these are still being kicked back way, way, way too far. So we're going to have to find a way around that. So let's go ahead and first select these particles, and let's try to make these to where they're not living quite so long, because otherwise this will bog down the system really quick. So let's go ahead and take this lifespan mode to something like a random range, and let's see what happens when we give this a smaller number. So now these particles should start to die a lot sooner, and consequently we'll keep our system running fairly fast. Okay, so we need to find something to actually sort of slow down these particles that are being kicked way, way back. So with these selected, let's add into this a drag field. And we can use this drag field to slow down the movement of these particles as they get thrown back. So for this drag field, let's see what we have when we just play this back. And you can see it as sort of slowing things down. Let's tell it to slow things down a little bit more. Let's say maybe a magnitude of 20 for this drag field. And probably going to have to be quite a bit higher than that. Let's try 100. Still going to need to be slowed down quite a bit more. Let's see about 500. Play this. Okay, that's getting to be a little bit better. Let's try maybe 1,000. So that's getting to be now a little bit better. And if we wanted to, we could maybe even take this up a little bit higher, maybe something like, let's maybe go back to 500. And let's see if we can maybe adjust this gravity a little bit more. Take this gravity and let's say maybe give it a magnitude of something a little higher, maybe 50. So that way we can sort of keep some of these going up a little bit better. Okay, so that's not bad. I can live with that. So that's how we can get these particles that are sort of coming up out of this surface. So let's take these, and let's take these particles and set them to a software rendered. Let's go with a cloud. And let's take the radius down on these, maybe something like 0.2. So now we've got these particles that are being kicked up out of the water. And I'll go ahead and maybe make this a little bit more random. Maybe take the random stream up a little bit. And all in all, we're still going to need a lot more particles than what we've got here. So let's try kicking this up to something like 3,000. So there we go. Now we've got the particles that are coming out of our scene. So I'm going to maybe go back to my attribute, and I still probably want the gravity to come down on these a little bit harder. Maybe the drag field. Let's maybe try taking this up even more, because these particles are still flying back quite a bit more than probably what I would want. That is a little bit better. Okay, so let's take a look at what we've got so far. So you can see when we render this, we have a few issues, a couple of issues. One, we actually have blue foam that's coming up out of this. You can see these little blue bits of mist. These are the actual particles themselves. Okay? And another issue that we can see is that these particles probably are definitely not coming down as fast as they should. We probably want to have the particles actually falling back to the ground quite a bit sooner, rather than having been kicked all the way back here. Now, one thing that you probably should definitely take into consideration is that the distance and the power that these particles are going to be kicked up at is dependent on the speed of your rotation, or the movement of whatever object happens to be striking those particles. So, in other words, the faster these paddles hit these particles, the further those particles are going to fly. So that's something to keep in mind. So let's go ahead and select this gravity field, and let's increase this a little bit higher, maybe something like 50. And that hopefully will let these particles fall down a lot faster. And let's also select these particles, and we'll go to the particle cloud. This particle cloud is what's going to be controlling the actual color of these. So if I select this blue color and maybe set it to a white, maybe something sort of a gray color, and let's maybe try lowering this density a little bit, and let's actually take this particle shape, maybe give these particles a little higher thickness, so that we actually have a little bit more dense foam, or a little more dense mist that's coming up out of here. So when I play this back, we should see something that looks a little bit more mist-like. So if you look, now you can actually see the mist that's being kicked up from these paddles. Now in our final render, we'll probably want to take the number of particles up quite a bit, because you can see that this is pretty sparse particles. But I really don't want to do that until I have to, because otherwise it's going to start to slow down my system. Now, one thing that I probably definitely need to do is let's take this plane and let's actually hide it. Control H. Now it's still in the scene and the particles will still be calculated. It's just now we don't have to worry about accidentally seeing that polygon plane in our scene. So in the next lesson, we'll start to go in and add some smokestack, or some smoke that are coming out of these smokestacks of the paddle boat, and then we'll make any final adjustments that we need to before we actually finish out this paddle boat.